Hi students, in this video we are going to discuss about stars seem higher than they actually are. So this is the point we are going to discuss. This is the concept we are going to discuss point by point. At first, point number one. Stars are, at first, point number one. Stars are independent stars are independent sources of light, situated sources of light. Now point number two, light from a star travels first in vacuum and then enter enters into earth atmosphere. Once again, I am repeating these 2 points, my dear students. Stars are independent source of light. That means which will be twinkle itself. Now, second point, light from a star travel first in vacuum and then enters into the earth atmosphere. Now, point number 3. Light from the star travels from rarer to denser layers. Therefore it will be bends. Therefore it will be bending every time. Bending every time towards normal. Once again I am explaining this point. Light from the star travels from rarer to denser layers or denser medium, bending every time towards the normal. Therefore the final refracted ray the final refracted ray is the final refracted ray is is the is the apparent star is the apparent star is the apparent star position apparent star position apparent star position is higher than the higher than the higher than the actual star higher than the actual star actual star position actual star position. Once again, the final refracted ray is the apparent star position is higher than the actual star position. For this one, I would like to draw a diagram to make you understand easily. Now, I draw a diagram here. Consider this is a earth. Here there are number of the layers are there. Whenever we are coming from up to downward direction, as a result, here the density is increasing and also the refractive index also increasing. Now, here there is one observer. Here there is one observer. The light is coming from star, which is coming from denser to rarer to denser medium. So it bends towards the normal. Once again, light is coming from rarer to denser medium. Once again, it is bends toward the normal and reach to the observer. That means it is the actual position of the star. But while the observer is observing, his eyes are from denser to rarer. That means away from the normal. He is observing from denser to rarer, away from the normal. Like that, because of that reason, he is observe the same star here. Therefore, this star we called as a apparent star position or apparent star position point B. This is we can call as a actual star position capital A. Capital A. This is point A, point B. Actually, where the star is, actually the star is here. But when an observer is observing from the ground, the star which is observed at a point B called as apparent star position. Now, this diagram supports this point. Once again, go back to our point. The final refracted ray is the apparent star position is higher than the actual star position. Okay, that means the final refracted ray from down to up is the apparent star position is higher than the actual star position. Actually, star is here, but the appearance of the star is at point B called as apparent star position. The reason is whenever the light is coming from upward to downward direction, the density is increasing, refractive index is increasing. This is the reason. However, I hope you understood this concept. Now, we are going to discuss about the advanced sunrise and delayed sunset. Now, we are going to discuss about advanced sunrise and delayed sunset. Now, take the earth. The whole dotted lines is atmosphere. It is atmosphere. Atmosphere. Now initially the sun is at S. He is slowly rising. Consider there is one horizontal or horizon which is touches the surface of the earth. Which is touches the surface of the earth. This is the line. Okay. Now if a person who is observing from the horizon, even though the sun is at a point S, he observed that the sun is at S1. This is called apparent of sun. The reason is the sunlight enter into the atmosphere and after that bends towards the normal. Once again enter and bends towards the normal and finally reach the eye of the observer. As a result, but whenever he can observe the light from his eye away from the normal, away from the normal, away from the normal. As a result, even though sun is at S, he observed that the sun is raised and its location called apparent location is at S1. That means the sun is raised 2 minutes earlier than actually whatever he is. Okay, now this is the diagram. For this diagram, I would like to give the explanation. First, draw the proper diagram in your notes. Now, point number 1. The sun is below. The sun is below horizontal or horizon. The sun is below the horizon. Appear to rise to S1 just above the horizon. Just above the horizon. On account of atmospheric refraction. Once again, I am repeating the point. The sun is actually below the horizon, appears to rise to S1. The diagram I already drawn. Just above the horizon on account of atmospheric refraction. Now, point number 2. The difference in time the difference in time involved is 2 minutes. 2 minutes. 2 minutes. That is the sun That is, the sun appears, the sun appears to rise, appears to rise 2 minutes, 2 minutes, 2 minutes earlier. Once again, I am repeating this point. Because of that reason, the sun differs in time. Involved is 2 minutes. That is, the sun appears to rise 2 minutes earlier. Okay, so this point support the diagram. Now, advanced sunrise. That means these 2 points are the reason. Now, delay of the sunset, that now we are going to discuss. Now we are going to discuss about delay of sunset. Consider it is the earth. This is the atmosphere. The whole one is atmosphere. This is atmosphere. Now the whole one is atmosphere. Obviously its refractive index is more, density of the air is more. If suppose the sun already setting, that means the point S is the setting of the sun or sunset ho gaya. Consider it is the horizon. It is the touches the surface of the earth. If a person is here observing, a light is coming from the sunset, enter into the earth atmosphere. Once enter into the earth atmosphere, it is bends towards the normal. After that, once again bends towards the normal. Because a light ray is entering toward the surface of the earth, its refractive index is more, bending is more, refraction is more. Therefore, it is bends and reaches the eye of the observer. But that means at the same time he is observing the sun. The light is relieving from his eye away from the normal while going upward direction. As a result, he can observe that light is or sun is at S2. But actually where the sun is at S. But he is observing that sun is at S2. That means it will become so 2 minutes delay. It will becomes 2 minutes delay. That means the sun, even though set completed, the light has been observed by the person on the horizon. It shall take 2 minutes time. Now we are going to discuss about point by point about this diagram or delay of sunset. Point number 1. The sun yes, the sun yes, which has which has already gone, gone just below just below the horizon, just below the horizon, appears to be yet S2, appear to be as yet S2, just above the horizon, just above the horizon, on account of atmospheric refraction. Atmospheric refraction. Now, the difference in time, involved is 2 minutes, 2 minutes, 2 minutes. That is the sun appear, to set 2 minutes, 2 minutes, 2 minutes later. Please observe these 2 points. The sun, yes, which has already gone just below the horizon, we already saw in the diagram, appear to be at S, S2, just above the horizon, on account of atmospheric refraction, Now, come to the point number 2. The difference in time involved is 2 minutes. That is, the sun appears to set 2 minutes later. Okay? From this one, what we understood? We understood that the length of each day increases by 4 minutes, by 4 minutes, on account of atmospheric refraction, Once again, I am repeating this point. The length of each day increased by 4 minutes on account of atmospheric refraction. What is the meaning for that one? Consider total day, total 24 hours. This is, we divide into 2 parts. One is day, second one is night. It is 12 hours. It is also 12 hours. This is we know actually. But what happened here? 2 minutes. 2 minutes earlier plus 2 minutes. 2 minutes late. Late gives 4 minutes. 4 minutes. That means how much time it is? It is 12 point. That is, it is 12.04 is the day. Similarly, 11.56 is the night. Like that, it is the day, it is the night. That means because of atmospheric refraction, morning we have 12 hours 4 minutes. This is a day. For the night, how much we are observing? 11 hours 56 minutes. Okay, what happened these 4 minutes? These 4 minutes came here. That is 2 minutes earlier, 2 minutes late gives 4 minutes. That is why the morning is 4 minutes greater than the night. Okay, so or the day is 4 minutes greater than the night because of atmospheric refraction. I think this is a new point and you understood this concept. Okay, however, thank you very much for watching this video. Thank you.